right, hi everyone. I'm trying to do a quick review so that we can get ready for this EOC. This review is kind of like basics, right? So I know that the questions on the big review were a lot harder, but this is just like, hey, remember these quick basic skills. Okay, so the first topic is absolute value, and what you have to remember to do is to split it. So look at the first problem. The 3 is on the outside of the absolute value sign. So I have to get rid of everything on the outside, just like normal. All right, so I'm going to divide both sides by 3. I get the absolute value of x plus 1 equals 3. All right, now, if this equaled a negative number, then I would have no solution, because when I do the absolute value of this number, it's always going to end up being positive. But we're good to go. It equals a positive number. So now that I've gotten rid of everything on the outside, we're going to split it. And I'm going to put x plus 1 equals 3. So it's the same exact thing minus the absolute value signs. And then I'm going to say x plus 1 equals negative 3. I want to point out that it's the numbers on the outside that it equals. That's what changes value. Okay, not in here. So now I'm going to keep going. Minus 1, and I get x is 2. Minus 1, x is negative 4. Now I can always plug this in to check, right? If I go back to my original problem, right? If this is the original, I could go back and check. I could plug in 2. 2 plus 1 is 3. Absolute value of 3 is 3. 3 times 3 is 9. Plug in negative 4. Negative 4 plus 1 is negative 3. The absolute value of negative 3 is 3. 3 times 3 is 9. All right? Okay, so let's look at this problem here. There's a half on the outside, so I know I have to get rid of that. Now, I usually say to get rid of a half, I would multiply both sides by 2. That gets rid of the half. I now have x minus 3 in the absolute value sign equals 20. Now, some of my students will say, oh, I would divide both sides by a half. That's totally fine. I'll get you the same answer. All right, now I'm going to split it. X minus 3 equals 20. X minus 3 equals negative 20. Remember, this is the stuff that's changing signs. Add 3 to both sides. Add 3 to both sides. Negative 17. Okay? Okay, now same thing on this problem right here, right? I have to get rid of everything on the outside first, just like normal. So to get rid of 1/3, I'm going to multiply by 3, multiply by 3. I get the absolute value of x minus 4 is less than or equal to 6. Okay, now I have an inequality. So this is where some kids, they totally forgot about this. All right, you know everything I've done so far has been the same, but now I have to keep one problem the same. I split it just like before, right? I just bring this right down and I get rid of the absolute value signs. But on this one, when I split it, whoops, get rid of the absolute value signs, sorry. I'm going to have x minus 4. And I know it's going to be a negative 6, but I have to flip that as well. Okay, so the first one is exactly the same. The second one, this part is the same. I flip the inequality and I bring down and I make that a negative. Okay, now I keep solving. Add 4, add 4. Add 4. So I have negative 2 and 10. I mean, I know this is not a perfect number line, but we're just trying to do this real quick. X is less than 10. This is greater than negative 2, and they're closed circles. Okay, so they're closed circles because these lines underneath them. Okay? All right, let's look at this one. So my first step is I'm going to multiply both sides by 2 to get rid of that 2. I'm going to kind of write it over here so I have a little more room. 5 plus the absolute value of x minus 8 is greater than 14. Okay, so I multiplied this by 2. The 2's cancel out. I multiply by 2, and that's how I got the 14. Okay, I can't split it yet. I have to get rid of this 5. So subtract 5, subtract 5. So now I have the absolute value of x minus 8 at 9, right? Okay, so now I'm going to split it. I'm just going to erase this to make a little room. My first problem is exactly the same. X minus 8 is greater than 9. And then here, x minus 8 is less than negative 9. Okay? add 8 to both sides, x is greater than 17. Add 8 to both sides, x is greater, did I do that right? X is greater than -1. Okay, now this gets a little tricky when I go to graph it. If I have a -1 here and a 17, I know that I'm like, wait a second, these are going the same way, right? That looks a little confusing. So the way that you have to think about it is you have to say, okay, if x is greater, hold on a minute. I feel like as if I did something wrong there. Did I not flip it? Oh, I didn't flip it. I did do something wrong. Okay, sorry. Let me go back here. I forgot to bring that down flipped. Okay, that makes a little more sense. So I'm saying x is greater than 17 and x is less than -1. Okay, sorry, I just hadn't noticed that. Now I could plug this in, right? I could say, okay, let me choose a number like maybe 20. 20 minus 8 is 12. The absolute value of 12 is 12. 12 plus 5 is 17. 17 divided by 2 is going to be bigger than 7. All right? Okay. Let's keep going down here. Now, some of my students got a little confused with this. So that's the absolute value stuff. Make sure you remember those. Simple interest. The formula is interest equals principal times rate times time. Okay, so I'm investing the interest. Now it's really important to see what the question's actually asking. It's only asking for the interest, okay? So I invest $3,000 at 6% annual interest for 7 years. Okay, interest equals principal. That's how much I'm investing. The rate, I have to turn it into a percent, right? Turn it into decimal, sorry. And the time is always done in years. So what I want to note here is that if you had to do maybe 6 months, if I said that the time was 6 months, you have to convert that into years and you would have to put 0.5 years here. Okay, but because I said 7 years and time is in years, we're good to go. So you're gonna get your calculator and you're gonna multiply those and you're gonna get that the interest you will have earned is this much money, okay? Now let's look at the next problem. It's similar, except for this time it's telling me that I wanna know the total amount I'm gonna have. So not just the interest. And the easiest way that I can do this to kind of make sense in my head is I'm gonna go ahead and find the interest. So interest equals principal times rate times time. So the interest is the principal times rate. I have to turn that into a decimal, times time, 5 years, okay? So when I get that, I calculate all that, I get 3,000. Now that is just my interest. So I have to add that back. Okay, so the total amount is gonna be that 3,000 plus the original 6,000 that I invested. So the amount is going to be 9,000. Now, some people were really like wanting to use a formula. I don't mind if you do that. To me, this kind of all makes sense in my head, and I just feel really comfortable with that answer. You can also use that the amount is the principal times 1 plus, but then you have to multiply the rate and the time first. Okay, so you have to multiply the rate and the time, then add 1, then multiply that by the principal, and that will still get you the 9,000, the total amount. Okay, all right, so let's jump here down to inequalities. And I know we did some inequalities up here, and I kind of just, extend it because I felt like I wanted us to have a little more practice. That was really focusing on the absolute value. Okay, so we have to remember, when we multiply or divide by a negative, we flip this inequality. All right, I'm going to divide by -3, divide by -3, x, that's going to get me -3, and I have to flip that. All right, so I have -3. It's going to be a closed circle. X is less than -3. All these numbers over here are less than -3. Okay, so this is an OR situation. This is a compound inequality. Usually OR situations look like, on the outsides or going in. So we're going to see what we get here. So the first thing I'm going to do is I'm going to subtract 10 from both sides. So I get x is less than -6. Or divide both sides by -2, When I divide by a negative, I have to flip the inequality. Okay, right now I'm a little concerned because I'm going, wait a second, these go the same way. This looks a little tricky, but let's see what we got. We got -6 here. Make sure you put the -6 there and the -2 here. Okay, so this is saying x is less than -6, so that means it's down here, or it's less than -2. So really, if you can be less than -2 or less than -6, it's really just saying less than -2, right? That doesn't happen very often, but I was just making up these quickly. Okay, so this one, what are you going to do first? You have, this is a compound inequality, an and situation, so usually it's going to be in the middle. All right, we're going to subtract 6 from both sides, so I have -6 is less than or equal to x, which is less than or equal to 6. So I have my -6, my 6, x is bigger than -6, smaller than 6, close circles, so I'm looking at that. All right, now with this problem, I made a mistake. I should have made this a -6 here, just make our lives a lot easier. So we're gonna go ahead and multiply. I have to get rid of this -2. We're gonna multiply everything by -2. And when I multiply by a negative, I have to flip these inequalities, okay? So -2 times -2 is gonna get me 4. Flip the inequality, those 2's cancel out. I now have x minus 3, flip the inequality, and I get 12. All right, I still have this 3 in the middle. Add 3 to both sides. 7 is less than x, which is less than 15. All right, 7, 15, open, open. And you can have one that's open and one that's closed, but okay. The next little section is about functions. So we remember, every x has to only have one y and vertical line test. Okay, those are kind of the two things that we want to remember here. All right, so is this a function? 5 has one answer, 1 has one answer, 6 has one answer. Yes, it's a function. Domain is x, range is y. I usually put them in order and don't repeat. Okay, so domain is 1, 5, and 6, and the range is y. All right, let's look over here. Is this a function? Does it pass the vertical line test? Yes, it does. Domain. The domain is in between here and here. So the domain, this is 0. So the domain is between 0 and 3. The range, the lowest is 1 and the highest is 3. So the range is between 1 and 3. All right, is this a function? No, it is not. It does not pass the vertical line test. Right there, you can see it goes through the pencil in 2 places. All right, the domain is like that 1 to 4, it looks like. And then the range, I know I go a tiny bit above. Let's act like I'm just touching that line. It's from 1 to 4 again. Didn't mean for that to happen. Okay, is this the function? Yes, it passes the vertical line test. The domain is all real numbers because it goes, you know, these arrows keep pushing it out forever. And the range is, the lowest point is right here at 1, but it goes up forever. So y is greater than 1 or equal to. Okay, now discrete and continuous data, there's so many ways that we talked about it in class. Remember, we said discrete was dots, continuous was connected. Continuous does not mean goes on forever. A lot of kids say that. It does not mean goes on forever. It means connected. Discrete is dots. Discrete is stuff I count. Continuous is things I measure. I can break down continuous items. So cans of soup, right? Cans of soup is discrete. If I were to, take inventory of how many cans every class of, had for 5 different classes, then I would, have 8 cans, 10 cans, 3 cans. No one's gonna have 6 2/3 of a can, right? So that's discrete data. Weight of the popcorn. Okay, if I was, keeping track of weights of popcorn, I don't know why I would do that, but I could have 2.3 pounds. When you go to weigh your, items at Publix or whatever, you get decimal answers, or you could. So this would be continuous. Length of your arm. I don't have to have a 1 foot, 2 foot, 3 foot. I can break that down so it's continuous, and the amount of people would be discrete because we count them, we don't measure them. Okay, flip a paper over. These should go a little bit quicker. I'm talking to you about a graph. Sorry. I'm talking to you about a graph, and we're just going to answer some key questions. Okay, some of them are really quick and easy. The y-intercept here is 2, because it's touching the y-axis at, the y-intercept is 2 because it's touching the y-axis at 2. This asks for the x-intercept. The x-intercept is also 2 because it's touching here at 2. I did not mean to do that. And behaviors, so I'm looking at this arrow here going up and this arrow going down. So it says, so we always start off as x goes to infinity. So this is infinity over here, positive infinity, and that's negative infinity. So I'm looking at this side, so I'm looking at this arrow. And as I'm looking at this arrow, as the x is going this way, this arrow is going down. So as x is going to infinity, y is going to negative infinity. As x is going to negative infinity, now I'm looking over here, this is going up to positive infinity. Y is going to positive infinity. Okay, where is the graph positive? So the graph is positive wherever it's above the x. All right, so it's above the x, this part. So where is it above the x? This entire section over here, I'm looking at the domain. So a lot of people say, oh, it's above 0, but that would always be the case. So I have to look at the domain this way. Where this way? Oh, right here. It's above the x until it gets to this pencil going this way right here. Okay, so it is positive when x is less than 2. Where is the graph negative? Well, it starts being negative right here. Okay, where x is greater than 2. Where is the graph increasing? Okay, so it's only increasing in this one little section here. So it's increasing between -1 and 0. It's decreasing here. So it's decreasing when x is less than -1, right here, until it gets to -1. Then it's increasing, and then it's decreasing here again. It's decreasing when x is greater than 0. So a lot of times you'll see the same numbers repeated for increasing and decreasing, just like positive and negative. Okay, the domain. The domain is all real numbers because, look, it's going out, 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 both directions. And the range is also all real numbers because it's going up, 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 and down, down, down. All right, let's look at the next graph. All right, we're going to write this in slope-intercept form. So we start off, we know slope-intercept form is y equals mx plus b. The y-intercept is this guy right here. The slope looks like it's rise to run 1, rise to run 1, go down 2 over 1. Okay, so the slope is y equals 2x, minus 1, sorry. Minus 1. Okay, so this is slope-intercept form. This is slope-intercept form for this equation. Okay, standard form. So standard form is ax plus by equals c. All right, so now I have to get this over here, which means I have to subtract 2x from both sides. So I'm going to put 2x plus y equals -1. Now I do not want my a to be negative, so I'm going to multiply everything by -1, and I get 2x minus y equals 1. All right. Now, this next part here says we're going to write an equation of a line that is perpendicular to this line. So we have this line right here, and we know this equation. So I'm going to rewrite this equation. The equation I'm writing right now is the equation for this line that's currently there. And the question is saying, we have a new line, and this new line is perpendicular to this line. Well, we know there's lots of perpendicular lines to this, right? But it's saying the particular perpendicular line goes through this point. All right, and there's 2 different ways you can do this. All right, so first, let's talk about what the new slope is going to be. That's going to be the first step either way. So if this current line has a slope of 2, and it tells you they're perpendicular, perpendicular slopes have opposite reciprocals, okay? So the slope of this line is 2. So the new slope needs to be opposite, which means it needs to be negative. Opposite is negative, positive, and reciprocal is flipped. Well, this is 2 over 1, so it's 1 over 2. So the new slope is -1/2, okay? So if I'm trying to straighten out my mind, I can say y equals negative 1/2 x plus b, because I know that's the new slope. Now I have two options. I can plug these coordinates in and solve for b. All right, so this is the y value. So I'm going to say negative 2 equals negative 1/2 x is 2 plus b. And then I can solve for b. Negative 2 equals negative 1/2 of 2 is negative 1 plus b. Add 1 to both sides. Negative 1 equals b. So then I would say the new equation is y equals negative 1/2 x minus 1. Okay, that's one way to do it. The other way to do it is point slope. Y minus y1 equals m times x minus x1. All right, we already calculated that the new slope was going to be negative 1/2, right? So we can fill that in. This is the x value. This is the y value. Since it's minus negative 2, I'm going to say plus 2. Okay, now I can distribute that since I probably want this in slope-intercept form. So distribute that. Y plus 2 equals negative 1/2 x plus 2. I'm sorry, plus 1. Right, negative 1/2 of negative 2 is positive 1. Minus 2 from both sides. See how we end up with the same thing. All right, over here, I just wanted to remind you, this is quick. If you're trying to write an equation for this line right here, it's a vertical line. It's going through negative 3. It's just x equals negative 3. All right, sometimes we get confused about the x and y situation. It's going through the x. So it's x equals negative 3. For a horizontal line, it's going through the y. This would just be y equals 2. All right, correlation coefficient. I know people definitely forgot about this. I can't imagine there's going to be a ton of questions on here, but what I want you to think of is if you have 1 here, negative 1 and 0, when it's near the 0, it's considered weak. All right, so the closer, and that's as far as it goes. There's not going to be like a 1.3. This is every single correlation coefficient is going to be in this range. The closer it is to 1 or negative 1, the stronger negative it is. And the closer it is to 0, the weaker negative. All right, so if we have to look at these numbers, we're going to look for the strongest. And it doesn't matter if it's negative or positive. It could be really strong negative or really strong positive. It's not asking us that. It's just talking about the strength. Okay, so the one that is, this is closest to 1, so this is going to be the strongest. Then the next strongest is going to be 0.4. And then this one, because it doesn't matter if it's negative or positive, I'm just looking at the numbers that are closer to negative or positive 1. Closer to 0 is going to be really weak. Okay, so down here, people were kind of having a hard time with this one. Okay, so the best way that I can do this is I kind of turn this into a little chart here. Okay, I'm going to put some numbers just because I think it'll make it a little bit easier. I might have to grab a sheet of paper just for room to help explain it a little bit. Okay, I'm going to write on the back of this. So if we look here, right? So what happens that can get, maybe I'll just write on this paper. Okay, so when I'm looking at this, what I've done is these dots are what actually happened. And this line is the predicted value. It's the line of best fit, okay, going through this. And we're trying to see if this is a good line of best fit or not. Okay, so what we do is we're just going to start off, and I'm going to start off here at 1. So the x value is 1, and the actual is the dots. So what actually happened here, and I always write down residual is actual minus predicted. That helps me get the right order, because in case you want to mix that up. Okay, so at 1, what actually happened is I landed on a 1. Okay? The predicted value was 2. Again, at 1 again. Now I'm still at 1. When I'm at 1, what actually happened is I landed, that's a 4, at 4. The predicted line was 2. At 2. I know I'm repeating these. That's okay. This isn't a function. This is a scatter plot. Okay, so at 2, What actually happened is I landed on 4. This predicted value was 3. Let's go to 3. At 3, I actually landed on 1. The predicted value was 4. At 4, I actually landed on 4. The predicted value was 5. At 4 again, see this is still at 4, I landed on 6 and the predicted value was 5. And then at 5, I actually landed at 5, at 5, and the predicted was 6. Okay, so that's just kind of my data from what actually happened to what is predicted to the line of best fit. Okay, so now I'm going to look at this. Actual minus predicted is -1. Actual minus predicted, 2. Actual minus predicted, 1. Actual minus predicted, actual minus predicted, actual minus predicted, actual minus predicted. All right, so now on my residual plot, right, if you look here, okay, so 1, 2, 3, 4, 5. It's almost like as if I'm taking this and turning it sideways. But let's go ahead and plot it. So at 1, when the x was 1, I got a point of -1. When the x was 1, I got 2. When the x was 2, I got 1. When the x was 3, I got -3. At 4, I got -1. And I got 1. And then at 5, I got -1. Okay, so that would be an example of my residual plot. Now, what you're looking for a residual plot to be good, you want it to be no pattern, right? So what you don't want, these would be really bad. You know, like if it looked like this, you want dots on both sides of the x-axis, but you want them to be scattered. You don't want to see a pattern. Like this is a pattern, so this is not a good line of fit. Okay, you also would not want this. Like these way up here and then these here. Yes, they're, you know, it's even, but it should be a little more centered. All right, hopefully that helps you. Sorry this video is so long. Have a good day.